It's late. It's late. I missed an important date. No time to say hello, goodbye. It's late. It's late. It's late. But waiting for the cable to do the final video capture was well worth the delay. The September 1989 issue of Compute magazine said that the Emerson 8000 EC Turbo XT computer talked, but by a May 1990 sale ad, it's just another computer devoid of speech capabilities in a sea of 286 and 386 computers. Does this computer speak? Or did Emerson Computer silently mute this computer? Does this computer even have any of its touted features or other hidden surprises that did not make it to a press release? Does it even boot? Or did I buy an overpriced boat anchor? That's what I'm going to attempt to find out on this episode of Computerized Start, the show where I explore the computers of my generation to inspire the next. My story starts with a computer. How does yours? I don't remember how I stumbled across this computer on eBay, nor do I want to admit to how much I paid for it, but something about this computer caught my eye. Perhaps it was the physical condition of the computer, as it had no signs of exterior rust, a sign that it may have been properly stored. Perhaps it was the claim of rarity that led me to verify the veracity of those claims. And I have to admit to being surprised at the time of finding 3 references to this computer in the Compute magazine archives. At this point, you're probably asking yourself, what feature could make one want to overpay for a vintage computer? And that would be the claim of a built-in speech synthesizer chip. But don't take my word for it. Let's look at the references to this computer that I found pre-purchase. In the October 1989 issue of Compute magazine, the News and Notes section describes Emerson Radio's entry into the PC market. It makes stereos, televisions, and microwaves. Now it makes computers. Emerson, one of the leading home electronics producers, has leaped into the personal computer market. Emerson's PCs have some features that set them apart from the average PC clone. Among those attributes are a 32-voice Signetics sound chip, MS-DOS 3.3 in ROM, and an online MS-DOS help program that not only displays on-screen instructions, but says them as well. This line includes 3 models, which includes the 8000 EC, a 10 MHz 8088 computer with 768K of RAM and 4 open expansion slots, $999 retail. In the November 1989 issue of Compute magazine, the New Products section again heralds this new line of PCs. Emerson Radio has introduced a new user-interactive personal computer line designed to make computing more personal by instructing users with a simulated human voice. The Emerson 8000 EC, a line of 10 MHz 8088 powered XT compatibles, comes equipped with 768K of RAM and an 8087 math coprocessor socket. In addition, the 8000 EC line offers built-in CGA or Hercules graphics, room for 2 3.5-inch or 2 5.25-inch disk drives, DOS 3.3 in ROM with voice instructions, a parallel and a 9-pin serial interface, a 101-key AT-style keyboard, bundled application software, and hard disk expansion options up to 40 megabytes. Oddly, the 8000 EC is only described as having DOS in ROM with voice instructions. Reading further, we find that the 8286 EC AT compatible is the one described as having the male/female voice synthesizer chip, and that the 8386 EC model includes all the features of the AT-compatible computer. I found one last reference to Emerson 8000 EC in the May 1990 issue of Compute magazine, this time in a paid advertisement from Lyco Computer. Yeah, it was on sale for $549.95, a discount of $450 off its original MSRP. Potentially not the best bargain at this point, as there is a Laser Turbo 2 starter system in the same ad for only $389.95. Needless to say that I became the proud owner of a so-called talking Emerson 8000 EC back in May 2020. And because I was in the process of trying to sell a house and buy another, I put it right on a shelf after double checking that it didn't have any immediate attention required concerns. Fast forward to earlier this month when I live streamed inspecting this computer to see if I could determine its actual specs. I did a web search to see if I could find any additional information on the computer, such as an archived manual. And that's when I found that the September 1989 issue of Compute magazine also mentioned this computer. And what did it have to say about Emerson Radio's upcoming line of computers? Well, in the Compute specific section, it asks, do we really need a new line of low-end PCs? In a surprise announcement at this year's Consumer Electronics Show, Emerson chairman William Lane introduced a 10 MHz Turbo 8088 XT, an 8286 AT, and 8386 SX. What's so different about these computers? Two things. First, Emerson's PCs talk. They have a new 32-voice sound chip, custom designed by Signetics, that gives them the power of speech. And this power is put to good use. Turn the machine on without the keyboard plugged in, for example, and you'll hear, "The keyboard isn't connected. Please insert the keyboard's connector into the proper input on the back of the computer case," or something similar. There's more. The Emerson PCs use proprietary algorithms to synchronize video with their sound. If you need help, a near video quality image of a real person appears in one corner of the screen and talks to you. Oh, really? Video on an 8088. Why does this now sound like the computing equivalent of concept car versus reality? And just when I was looking forward to something more personable, even if robotic, then a beep if I forgot to plug the keyboard in. Enough of me talking. I think it's time to see if I can get this computer to talk. Or at least do something to make me feel better about the money I spent on it. I'm fairly certain that the CMOS battery is dead, as those Dallas real-time clocks with the built-in battery don't normally last for 30 years. So if this computer is going to talk, it should say something when I power it up. I've placed my microphone over the computer so that you will be able to hear what I hear. And there's the expected CMOS checksum error. A beep. How quaint. If you're wondering, it doesn't speak if you forget to plug the keyboard in. It does, however, still expect you to press F1. I wasn't expecting it to take the date. I wonder if it actually set the century. MS-DOS 3.31. That was an OEM-only release, but not a bad version for an XT-class PC. Oh, the install in ROM is very bare bones. I had expected the setup program to be in ROM, however, I figured out that you access it by pressing Ctrl-Alt-Escape. The century is correct. Let me fix the drive settings, save, and exit. Oh, did it not keep the settings over a warm reboot? Well, looks like I'm going to have to replace the clock chip. Now let me run diagnostics. I'm going to run system board diagnostics. So far, so good. Well, that's a friendly failure. Let me see if the failure is consistent. The real-time clock passed that time. Hopefully replacing the clock chip will resolve this failure. But before I go downstairs to replace the clock chip, let me run a memory diagnostic. Not that I have any spare memory chips on hand. It passed the first time, but I'm going to go ahead and run it once more. Excellent. Looks like if I can manage replacing the clock chip without destroying any vias, then hopefully this computer will retain its settings and pass all of its diagnostics. Down to the workbench I go. To get the motherboard out of the case, you need to lift the drive and power supply carrier out of the way. And in order to do that, you need to remove the bezel. There are 5 screws, and I would recommend using a 1/4-inch socket to remove them. Also, you will need to gently pull the ribbon cable up and out. Be careful not to drop the power button, as there is nothing that retains it onto the bezel. To remove the drive and power supply bracket, there are 4 screws on the front and 5 on the back. Note that I missed pointing one out in the video. These screws may also be removed with a 1/4-inch socket. Before lifting the bracket out too far, unplug the power and floppy cables. You might be able to get away with not removing the power switch, but I didn't want to risk the drives falling onto the motherboard. Those screws will need a 7/32 inch socket. Now that the motherboard is exposed, let me point out some of the major components. The 10 MHz 8088 CPU, this one manufactured by AMD. The socket for a math coprocessor. I have one on order for a future upgrade because, why not? The BIOS chip. It's an AMD AM27C010, which is a 1 megabit or 128 kilobyte EEPROM. Larger in size than most XT-class BIOS chips, however, this one also contains the MS-DOS install. The G2 CG100A PC chipset. The original Dallas DS1287 real-time clock that I'm about to change. The marketed 768K of RAM as 6 Sharp LH64258 chips with only 640K accessible. Additional sockets for reasons unknown to me without seeing the manual. A UM82C451L, which I suspect is supplying the serial and parallel port. However, I can't find a datasheet to confirm that. An ACC 3201 floppy controller chip. An AMD AM27X64, which is a 64 kilobit or 8 kilobyte one-time programmable EEPROM. Yes, that's an oxymoron, but that's what the datasheet says. Given its small capacity and location on the board, it might be a ROM for the video controller or for the onboard IDE. The Paradise PVC4 video controller. According to Dag Eric's Retro Computers, this controller was used in the Schneider Euro PC, and that computer supports Plantronics Colorplus mode. That would be a nice surprise if this computer does as well. 2 Sharp LH2464 memory chips for 64K of video memory. That's enough to support Plantronics Colorplus mode. And other than a programmable array logic chip that I forgot to point out, mainly standard LS logic chips to round out the ICs on the board. There is one jumper on the board, and I don't know what it does. I tried changing its position, and there was no video output, and it did not sound like it was trying to boot sans video. I would not recommend changing this setting without referencing the manual. And there is one switch accessible from the exterior, which I believe toggles between CGA and Hercules video modes. If you're looking at the back of the computer, the left switch position appears to be CGA mode. If you happen to have documentation for this computer, or datasheets for any of these chips, leave a comment. It will help with future videos on this computer. Thanks in advance! Alright, enough of a tour. Back to removing the motherboard, which is held in place with 9 screws. I'd suggest using the 1/4 inch socket again. Now that I have the motherboard out of the case, I located the DS1287 chip on the backside. While it is in a 24-pin package, not all 24 pins extend outside the package, and Emerson did not provide through holes in the locations where pins do not exist outside the package. Since I am going to socket the real-time clock replacement, I will need to remove those pins from the socket. As for replacements, I have two options available. My preferred option is a GW12887-1 from the Glitchworks on Tindy. It is 100% compatible with the DS12887, but is made with a DS12885 so that it has a replaceable coin cell. If this proves incompatible for some reason, I also have a new DS12887, which the datasheet says is pin compatible with the DS1287. This option will eventually need to be replaced, so I would want that in a socket. However, if the Glitchworks replacement is incompatible, then I don't expect that the DS12887 would work either, so I would need to try to rebuild the DS1287 from this computer. Long story short, I need to use a socket as this motherboard probably won't take the repeated rework in the same area if I'm behind the soldering iron. Here I'm clipping the pins off the bottom of the socket. However, I have yet to notice that via, which is going to be right under one of the pins, which exists on the GW12887, so I will later prepare another socket removing the pins using heat in order to avoid an accidental short. Oh yeah, I just realized that Heisenberg would be happy to solder the GW12887-1 repair boards I also ordered for future computers, as the PCBs are blue.
Ooh, shiny.
It's time to desolder. I'm going to try my best to keep the work area under the camera and unobstructed by the smoke absorber. Speaking of rework, I invested in an NSD ZD915 desoldering station, and this will be the first time that I will use it. I'm hoping that this will help improve my rework game, because I can't afford to keep destroying boards while attempting to repair them. If anyone is curious, I have the desolder station and my soldering iron set to 650 degrees Fahrenheit for use with leaded solder. I will be using Amtech VS213ATF no clean flux for desoldering. After using the desolder station, it felt like there was still some solder, so I am using my Goot Wick to try to wick up what the desolder gun missed. I got the DS1287 out, but some of the holes weren't clear enough to insert the socket, as the socket's pins are larger than the DS1287's pins. I tried the desoldering gun to see if it would suck the solder out. No dice on that, and in hindsight, that was probably a bad idea. So it's back to more Goot Wick and Amtech Flux, along with a turn at trying the Engineer Solder Sucker. Once I finally cleared the solder enough to insert the socket, I cleaned the flux off the board using 99.9% isopropyl alcohol, or isopropanol if you prefer, since this motherboard is too large for my ultrasonic cleaner. I used a paper towel to carefully absorb the excess IPA from the board to reduce the amount of time for the IPA to evaporate. And it's at this point where I noticed the via that could come into contact with the clipped socket pin if I managed to get the socket mounted flush and the pin clipped not so flush. It is also at this point where I didn't realize that the work area was not in frame. Off camera, I was very carefully using the heat from my soldering iron to push the pins out of the socket. Except for one uncooperative pin that kept bending over instead of pushing out. Since there was nothing on the motherboard that pin could short against, and it was in a location where a real-time clock pin would never be present, I gave up trying to extract it using heat and simply clipped it flush. I then inserted the modified socket into the motherboard and used Kapton tape to hold the socket in place. You know, in hindsight, maybe it's just as well I didn't show that procedure. I'm sure I would have received comments about how that was dangerous using the soldering iron in that way. There's only one thing left to do, and that's solder the pins. I tried using the flux and the solder alone, but the solder wasn't flowing well enough on its own, so I added more flux. I was trying not to have to clean the board again, but good solder joints are more important. After inspecting the joints under the microscope, I decided a few of them needed additional work as I had not sufficiently filled the joints. I then cleaned the flux off the board. It's no clean flux, and even being on the underside of the motherboard, I would know it's there. And there, the socket is in place. I'll show the pin that I wanted to remove, but resorted to clipping. I noticed a few solder joints that still didn't look right after cleaning the flux, so I touched those up with a little more solder. Then off camera, double-checked the continuity with a multimeter, because my camera was not cooperating with focus. And there is the finished repair. The blue PCB on the gold PCB looks nice, and I don't know why. Anyways, I was running out of time on my SD card and could already tell this video was going to be longer than I estimated, so I opted to reassemble everything off camera. Just follow the disassembly in reverse and you'll do okay. And I have to admit, I considered stopping part 1 at this point, but I hate cliffhangers too. So far so good. I expected the CMOS checksum error since the real-time clock is brand new. And no surprises during this boot attempt. I might as well set the time and date now, as it will be retained. First, I will run setup to fix the drive settings. It's no longer complaining about the low battery. Excellent! I'm taking a moment to double check the specifications on the floppy drives. I had previously guessed that they were 360K ones, but I just confirmed that to be correct. I guess it's good that the computer will support high-density drives. Future upgrade option. I saved and exited as I want to see the computer boot without error. And other than DOS claiming I didn't set the year, the computer booted to ROM as expected. I'm going to run system board diagnostics a few times. The real-time clock passed all 3 attempts. That previous failure must have had something to do with the dead battery. For good measure, I'll run the memory test a few times too. I'll speed this up because the video is getting long and because the memory still passes. Looks like I avoided collateral damage. And now for the ultimate test. I will verify that the settings are retained across power cycles. I powered the computer off for about a minute to make sure all the capacitors discharged, then powered back up. Nice! No more CMOS checksum error on a cold boot. Before I go any further, I want to install my low-tech XTCF Lite Revision 2 and my Resound 2 OPL3, both of which I purchased from TechSelect. I decided to go with the Resound 2 OPL3 as it is AdLib compatible. I also have their CMS Game Blaster clone, but the game I've chosen for testing supports AdLib. I also decided to replace the screws holding the expansion cards into place with better screws. You might notice that this video capture looks different. It is. The previous captures were done using an 8-bit VGA card while I waited for a cable to connect the onboard video to my RGB to HDMI. That cable finally arrived. I've also skipped over some troubleshooting getting the XTCF to work which I will have to recreate for a shorter future video. Oh nice! I have color on the screen! And not nice, the capture card started dropping frames, so the audio and video are now faster than real time. To test video modes, I'm going to use Planet X3, as it supports all of the CGA modes that this computer might also support. First up, CGA 320 by 200 4-color mode. I'm not surprised this mode works. I'm going to start a game so I can show the various color palettes. Yeah, 4-color mode is what it is. Have a nice DOS. You're too funny, David. Since this computer does not have a composite output, the next mode up is CGA High-Res Mono. I'm also not surprised this mode works. I believe the CGA 4-Gray mode is for playing on laptops with monochrome screens, so I'm going to skip it and go straight for Plantronics 320 by 200 16-color. Fingers crossed, and... woohoo! Surprise! This computer does support Plantronics Colorplus mode. And while I'm sure Planet X3 looks great in VGA mode, which I can't test on this computer, there's a certain je ne sais quoi about 16 CGA colors. It feels appropriately retro. I'm taking a little consolation prize dance here, but I didn't intend for this to be a Planet X3 playthrough video. Perhaps I'll do that in an upcoming live stream. Okay, dance party over. I really do need to get editing if I'm going to make this DOScember. I might be fashionably late, but maybe it will still be DOScember in another time zone. Well, folks, there you have it. I gave this computer ample opportunities to talk if the Signetics chip was hiding inside, but it looks like that feature either never made it into the 8000 EC, or it was removed at some point in the production run. I'm thinking it was the former. However, it does appear as if this computer supports Plantronics Colorplus mode, which was a pleasant surprise. Unfortunately, it does not appear that many programs ever supported this mode. However, Planet X3 does support this mode as of an August 2020 update, so this seems like a good computer for playing through Planet X3 in the best of the CGA color modes. So, what are my closing thoughts on this computer? On the positive side, it isn't an overpriced boat anchor. The computer did boot, and only required replacing the non-socketed, but at least through-hole, real-time clock chip. Many computers of this age have suffered from bad memory and failing logic chips, so that is worth something. Having Plantronics Colorplus mode support was an unexpected feature, and is probably worth something too. On the negative side, this particular XT clone is more limited than others. While it does have onboard features that would require add-on cards on other XT clones, that comes with the limitation of having only 4 ISA slots. The video card cannot be disabled, so while this isn't the computer for VGA gaming, it's going to cause you issues if you really want to use a different video card. I would have probably preferred 8 ISA slots and having to use expansion cards for everything. But its main selling point, the built-in speech synthesis chip, doesn't exist. And the built-in MS-DOS and ROM is not very useful, and potentially crippled. I had trouble getting it to work with a Gotek emulating 3.5-inch floppy drives. Unfortunately, I think I still overpaid for this computer. Not every retro PC can be the DOScember Christmas miracle. And with that, I'd like to thank you for joining me on this exploration of the Emerson 8000 EC computer. And if you've stuck around this long, why not like this video and leave a comment as to what you would like to see run on this computer. If you like what you've seen, please consider subscribing, and if you would like to feed my habit of overpaying for retro computers in the hopes of exploring the computerized start of my generation, please consider supporting me on Patreon.